The problem is symmetric tree. The approach is recursion. The language is C++, which is quite irrelevant, but it is what it is. And it's quite simple. Let's get into it. Assuming we just have a root node, that being 1, we return true. If we have a left node and a right node, we compare our left node with our rightmost node. In this case, 2 and true, which would 2 and 2 and 2, which would be true. These are also binary trees, so we go down again and we compare the leftmost node with the rightmost node, 3 and 3. And we compare the rightmost node with the leftmost node, in this case 4 and 4. And the output obviously is true. We have a symmetric tree. Before we get to implementation in C++, did you know you could actually alter the test cases used in LeetCode? If I add 9, hey, look at that, my binary tree grows. That's just a fun thing to do. Let's go ahead into our implementation. Yes, I know I have started recording. Very helpful. As you see, it is a blank file only consisting of the class definition and a function definition, as well as the structure tree node up here. Let's get into it. So the simplest thing is if our root node is null pointer, in that case, we return true because we have nothing. Therefore, we have everything. Now, as I said, recursion. All we're going to do is return some recursive function. Return recursive. That's not right. Recursive function. And you can call it whatever you want. In my case, because this is C++ and I can do function overloading, I'm going to call mine isSymmetric, and I'll pass in the left node, and I'll pass in the right node. That's not correct. That is correct. So evaluates to true or false. And then we implement our recursive function. And because of function overloading, I need to change the parameter signature. So I have my root, but I will also pass in stake a left node, and it should be a tree node. Right node. That should be correct. And then the first case is if left node is equal to null pointer and my right node is equal to null pointer. In this case, I return true because both exist. Both exist as null pointer. So both are equal as essentially nothing. I then have if left node is equal to null pointer or right, that's not right, or right node is equal to null pointer. In this case, it's false. And why is that? We have 1. We have 1 as nothing and 1 as something, and my dog is barking. Therefore, false. That's just not true. Let me also make it explicit. This is, because it's a recursive function, we have our base cases. A base case, this is also a base case. We also now have our null pointer. We have another if left node, the value at left node is not equal to the value at right node. In that case, return false. So we check the correct positions, but the values are incorrect. Recursive case. And finally, all we do is return is symmetric using left node. Base case. This should be my recursive case. Left node will go to the left. My right node will go to the right. But I don't just stop there. I have to do the logical operator and do is symmetric. Left node, right, and right node, left. And that is all. Once we implement these functions and we do a run, we get back our output as 2 successful cases, and if we submit, we get a successful completion, a runtime of 3 milliseconds and a memory of 17.21 megabytes. Not bad at all. But that was it, a very simple function created to determine if a given binary tree is a symmetric tree.